Okay, cool.
Okay.
All right. And yo, we're live, dude. We are finally live. All right.
All right, cool. Let's go.
Okay, cool. See, you've got your Take a Lot shirt, you know? You're having some nostalgia there.
Yes, they must pay me for advertising.
Yeah, promoting the brand.
Yes. Stuff. Yeah, sure.
Yeah, so obviously there's many ways we can take this episode, but I just wanted to maybe touch on some of the interesting things that maybe you've picked up in your radar in the tech space. I don't know if there's something cool you want us to chat about.
Yeah, no, there's a lot, but then I'll jump into the one that just popped up in my mind when you said that was the Ethereum upgrade. So the London Hardfork, pretty much, aka what, EIP1559. So we can talk about that. And yeah, and on your side, what's been happening? What's cooking?
Yeah, you know me, I love to keep my eyes on the hardware space and see what's cracking there. So one thing that's been really exciting is that Alphabet, which is the holding company of Google, basically have created a new division called Intrinsic. It was already basically part of Alphabet. They've just now chosen to basically make it a separate entity. And so this entity is focusing on getting into the industrial robotics space. So basically, Google wants to get into that space and see what kinds of innovations and problems they can solve there. So I find that really exciting. I think we can chat about that and see why that matters and what that means for the average Joe.
Why not?
All right. Awesome.
Cool. Let's get to it then. So I guess we'll just talk about those two topics and then we'll see where things go.
All right. So what does EIP stand for? Like Ethereum EIP?
What the acronym?
Yeah, the acronym. Yeah.
Okay, it's I think I've forgotten about it. Ethereum EIPO, Ethereum improvement proposals.
Okay.
EIP, yes. Same thing I think for Bitcoin, BIP, Bitcoin improvement proposals.
Okay, so this is like an open source kind of. Do you know how they basically manage this proposal program?
Essentially, it differs per project in the blockchain space. So for Bitcoin, for example, how they name it, how the number after EIP, it differs depending on how important or which part of the code they're trying to change. It could be, let's say, 1, 1, 1, 2, 3, 4, whatever. But then for Ethereum, the number is just incremental. Okay. So the one that was proposed, which is the EIP1559, was proposed, I think, 2-3 years back, or whatever. And then it's been in the system, pretty much people debating it, like the usual stuff, debating it, the pros and cons, looking at it, pretty much going deep dive on this thing that you propose. Can it work in the network? Who can we consult about this? Who needs to actually come in and then do whatever they need to do on that? And then eventually, now it's being implemented. It's live. I think last Friday or Saturday, somewhere there, it went live. And so now it's just
by live you mean like testnet live, production live, mainnet live, or basically just running?
It's on the mainnet. Yes, it's live for on the mainnet, live. So everybody can use it now, or people are using it now, and then they're seeing the impact of it. Before, obviously, as usual, it's just speculation. Having your research, having your projection on what can happen in the system. But then in the past, I guess 3 days, whatever, we've just been monitoring the actual impact of it. And yeah, that should be fun.
Okay. So let's get into it. You're Mr. Fundamentals, all right? You love to preach the gospel of fundamentals. So what are the fundamentals here? What is the proposal? What is it actually changing compared to what we have today?
So I guess one big part of it that they're trying to change is just making sure that the gas price is more predictable, less volatile as it is right now. So right now, if you think about the gas price just changes dramatically, and then the users is difficult to measure up on what's actually or predict what's going to happen in the future. And that's bad in terms of usability. That's one aspect of it, right? So just to make the whole thing less volatile. So, and then it adds another element, which is banning of transactions, right? Some other people will say this trying to make Ethereum deflationary instead of inflationary, which is currently how it works. And also, what's the impact of that on the actual miners, right? So let's now go back to the original one. So what they did now is cool. They know, okay, cool. So let me just go back just a little bit, just to give the actual problem. One of the other problems besides the one I've mentioned in the beginning. So if you have right now a lot of people, a lot of users, how they essentially use Ethereum, for you to, let's say, to make a payment from point A to point B, you need to pay transaction fee. That's number one. So now question is, who controls that transaction fee, the amount, right? So essentially that's left on the miners. So it's sort of kind of an auction where you need to now put the big amount that can make the miners happy so that they can take your transaction and then mine it, and then off you go. So that amount, obviously, because now it's determined by the auction, like with any other auction, it goes for the best number there is.
Yeah.
So they're trying to make it more predictable. So how they did that, they introduced, they split the concept of a transaction fee into two elements. So the first element, which is a base fee, the other element is a priority fee, right? So the base element is essentially the bare minimum amount you need to pay to be eligible to go into a block. That's number one. Priority fee, as it says, if you want to be prioritized by the miners and whatnot, pretty much following the same system that we currently use or the previous system that we're using, you just need to put more money on there, and then boom, your money will go out. So, but then all of that, so the base fee and the priority fee, from a practicality standpoint, how you do it is you can give like the maximum amount you're willing to pay if you're trying to make a transaction. Based on the maximum, right? So if you put it maximum, the maximum should be the priority fee, the base fee plus the priority fee. So now, if once it goes in there, if your maximum you're willing is like, let's say, you didn't like, okay, it depends actually. If you're using, let's go back. If you're using the old system and then you're using an old client, right, for Ethereum, and then you're trying to use with a new node, which is the one that implemented the protocol. What it will do is that, because before you just specify the big amount, and then the miners will look into your transaction, and then if you have the biggest amount that's attractive to them, they'll take it and then mine it. Right now, if you come in with that same way, so what will happen is it will take the new node will take your base, right? And then if whatever that's left is pretty much going to give it's going to make it a priority fee.
Priority fee. Okay.
Minus. Yeah. And then if you're coming with a new one, it's essentially just going to give you, if you have, let's say, a big amount, you have the base fee plus the maximum amount, which is, let's say, the priority fee. Whatever that's left, pretty much they send it back to you. It becomes a refund. So there's a refund mechanism that happens as well. So from a user standpoint, that's more predictable instead of the current model where you can actually send money into the Ethereum network, and then because your fee that you've stipulated is not good enough for the miners. Your transaction can actually be a pending transaction, being there for a long time to a point where it doesn't actually get mined, or take it for a very long time for it to get mined. Instead of the typical, let's say 30 minutes or 15 minutes, whatever, it's probably going to take a couple of days because there's other higher priority transactions in front of it. Cool. Let me stop there and then we'll jump in.
Okay, cool. So let me just to summarize. So basically, you've got a change in the protocol that's resolving an issue associated with basically varying fees depending on the state of the network. And we all know that one of the issues was when obviously Bitcoin or Ethereum is at a high price, trying to send money is like insane. Like I remember, I think we both were sharing this, that trying to transfer Bitcoin like 2 or 3 months ago when it was at its all-time peak could cost you like $24 just to move your money. And then tomorrow it can cost you 15 and another day cost you 8. So basically they're resolving this issue of giving you like a very predictable fee that you can basically rely on as a user. Now, the key question I want to ask is obviously for the miners now, obviously it makes it a lot better for us. It's basically driving.
But before the miners come in, one thing people need to understand is that this new change doesn't guarantee, or it's not meant to fix the high price amount, right? Okay. It's just to make it more predictable. That's all. Because right now, the number says people are actually paying way more than they should because they don't know what's the base amount. So they just put in more just to say, okay, let me get my transaction in there. But then they actually overpay. So we're trying to eliminate the overpayment part. So that's the new, sure.
Yeah, and that's because I guess the critical thing, which I think is the most important thing it solves, is basically hanging transactions. The fact that you can send a transaction, and because the miners are obviously not necessarily meeting consensus at your price, your transaction hangs. So basically what this solves mainly is not having dead transactions. Because what you'll do now is basically have your so-called base fee, which you can be guaranteed to some degree that it will be mined vis-a-vis the state of the network, etc. As opposed to today, what happens is that your transactions can hang. And if I understand, in order to resolve that, you basically need to get all Ninja into the Ethereum network and increase the basic transaction fee for the miners to get it.
Yes, either you'll cancel it or you do a replacement with a higher gas fee.
Okay. All right. Okay, cool. So it's more predictable. All right. Mm-hmm. And I can't help but think, okay, it's better. It's okay in theory, of course. It's been like 4 days. So nothing's collapsed yet. But what does this mean between the relationships of users, what they want, and obviously miners? Because I understand today miners get paid when they mine a block, for example. And obviously today they take the transaction fees. Now, an interesting thing you mentioned is that in this new protocol, the transaction fees are burned to some degree. So how does that not work against miners and incentivizing them to protect the network?
Okay, so the basics there is that for every base fee that happens per block, it's essentially get burnt, right? So the miners are only incentivized to get the priority fee and your normal block reward, which is 2 ETH, I think. So those are the only two. So even 100%, obviously the cost will go down. The revenue from a mining standpoint that will go down, but then the simulations doesn't indicate a lot. Like they won't go down by a lot. Definitely they will go down. And then I think in the past 4 or 5 days, they have been going down. So people have attested to it, but then not by a lot.
Okay, so it's not like a radical industry shift. So okay, cool. So
it could be, but then the other thing needs to, I guess, maybe talk about is, can those miners, right, can they take their hash power, move it to, let's say, Ethereum Classic, which is the closest one to Ethereum that they can jump into quickly without any issues? Maybe they can, but then if you think about the I guess what they can make in Ethereum Classic and what they can make in Ethereum will be obviously different, right? So most of them, they rather stay than leave because of the amount of money they're making versus other competition that they can go into.
Okay, no, it makes sense because it touches on this issue, because you basically broke down this metrics of, you've got the base fee, which is burned, they'll never earn it, but then you still have this priority fee, which is basically the extra fee you'd pay as a user to make sure that your block is mined quicker, faster, etc. And that they still earn. So naturally you could ask, wouldn't the miners now create cartels where they basically try and only mine priority fees, or force a situation where people just only constantly give extra for the priority fees, and as opposed to relying on the predictability of the base fee, which they don't benefit from? So there's that question of, like, to what degree in general
they can actually they with the banning. So to just pause that question a bit, with the banning, they potentially can get money out of it indirectly, right? So by banning those fees, if we get to a point where now the banning of fees versus the injection, which is the block reward, if that's bigger than the other, you can see a situation where we have Ethereum in a deflationary way, right? If it's deflationary, obviously everybody who's holding Ethereum, essentially they're making more money.
Yeah, the price goes up.
So it's not an obvious thing, but it's a potential. It can happen. So obviously that one we just have to monitor how the system works, and then I don't know, it might happen now. It might happen after the Ethereum was 2.0, 3.0, whatever. The new the
which
is coming.
We're still waiting for. All right.
Yes, the is still coming. So if that happens, it could happen whenever. But then there's a potential of that actually happening.
Okay, so in principle, it's not completely like a loss for the miners, but I still want to poke at it. Like, given that obviously, if I compare blockchain to normal everyday world today, I don't necessarily pay in theory, even though we do, for the banks to look after the security. Actually, we do through transactions.
We do? What do you mean?
All right, I just shot myself in the leg there. But in principle, from a consumer perspective, my incentive is obviously to get things quicker, faster, better. All right. And it seems like right now in blockchain, that might not correlate the incentives of miners to, let's say, earn money by just sending transactions, etc. So how does this relationship between future improvements, like the one that you've mentioned, play itself out with miners, and the fact that in the future, when you bring in something like proof of stake, we basically are chucking out miners almost completely from the ballgame. And the amount of money that they're getting now is basically it's temporary. So there's that kind of system in this ecosystem of users, nodes, protocols, miners, and all the applications that we're building. Don't we run the risk of incentivizing miners to start colluding as we make more of these improvements?
Okay, obviously, with any other system out there, there's the bad side of things. But then, if you think about it, we have users who are like, okay, let's say we actually have the users, the normal Ethereum users. We'll have your miners, we'll have the backend developers, and we'll have your dApp developers, right? So the backend developers is those guys who will be essentially interacting with the node, with the, I guess, Ethereum API, going to the node, getting transactions, making sure stuff happens and whatnot. That's the backend guys. So now, if every guy has a role to play. So right now with the miners, they should be happy if the users are happy because they get the network gets used a lot, and then they get to make a lot of money. So the more users we get, the better, right? Right now, users are complaining. So if users are complaining, they're essentially going to move to another protocol. So now we're trying to get to a point where pretty much we make everybody happy. So we have the previous system and we have the new system. So in the place of, let's say, Ethereum, not Ethereum, Bitcoin. Bitcoin, when they go to this point, that's where they split into Bitcoin and Bitcoin Cash, which is which way do we go? So now Ethereum is trying to now be in the middle. It tries to make everybody happy. So now, pretty much just to answer your question, they will be happy once the users are happy. That's my understanding of the whole thing. And then it's not that currently the proposals that are happening will actually slash their revenue by a lot.
Okay, cool. No, it makes sense. And I suppose you still have this protection of the 51% principle, which basically means that even if you got some angry miners, you still need to get them all to act unilaterally at the same time, of which at any point, if someone decides to quit the cartel, they'll benefit from everybody else trying to do like this digital boycott, if you can call it that. So I guess that, okay, cool. For now, the experiment is holding, but I just feel like once we get to that massive shift to proof of stake, I'm just not sure how you're going to get these miners who've invested all this infrastructure and hardware to basically, cease to be relevant. Like,
for me, under carpet, I think this is like a way for the Ethereum core developers to slowly ease into that space for the miners. Like they're just taking baby steps before they get to that. Like once they get there, they don't feel it. Right now, slowly they're removing that the part they love the most. So they're making them more comfortable with other aspects, just to broaden their view a little bit, to say, hey, this is actually possible this way. That's one thing I think is happening underground.
Okay, well, it's interesting, now we'll keep an eye on it. And I guess the bottom line is, I have to ask this, what does this mean for someone with a dApp on Ethereum today? Like, what would be the key things that they maybe would notice that's different between today and, let's say, 2 weeks ago? If they'll notice anything at all.
For the dApp, they should not. They should not. So the dApp side of thing, I think they should not feel a lot of changes unless, let me see, debugging, because the fee model, if I understand it, the fee model, like the fee before it was mined, the fee after it was mined is slightly different, or it will be different, because what you've put in, sometimes you get a refund and stuff. So from a debugging standpoint, you can think about it as a developer. It'll be difficult to do if something keeps on changing all the time. Mm-hmm. It's not like it's not predictable. It's not what you put in now will be what you have later. So that could be difficult. Let's see, dApp. Okay, because now I'm just thinking from a backend developer standpoint. Like obviously the APIs will definitely change. But then when they change, they need to be backward compatible. So obviously right now, the one that I know, the transaction fee, which is the one I highlighted 2 seconds ago, that's the actual one that people are actually talking about it a lot. Then in the future, obviously definitely it will definitely be removed. But then at the moment, they need to have it just to make sure that if somebody was using the same client as the old client before this upgrade happened, they can actually still transact and everything should be hunky-dory. Even though, let's say, you've signed your transaction 5 years ago, and then with the hope that after 10, pretty much you added a timer somewhere. You scheduled the transaction that, okay, please send this transaction 5 years from now into the blockchain. So that still should still be able to work at the moment. So yeah, those are the things I'm aware of right now. Probably there's others, but then right now those are the things I'm aware of.
Okay, that's fine. I think we've kind of like dug into that. And it's good to see Ethereum making progress, because sometimes they start to worry that it's starting to suffer from this monolithic stalemate, which we know blockchains have, where they just don't get anything done. People have many opinions.
I think it's doing a good job, right? I think it's doing a good job, because from my side, it might be undervalued versus to Bitcoin. Because obviously I'm biased because I'm a developer. I like Ethereum a bit more. But then what does Bitcoin does? Like, what can it do, right? So, and then it's like the amount of money and in terms of price, it's a lot versus to Ethereum. So Ethereum does a lot of these things, but then from a valuation standpoint, it's not valued as much as a Bitcoin. So for me, I'll say Ethereum is the way to go. But then my issue will be, okay, it's because the software can be changed all the time, then something else can replace it quickly. While with Bitcoin, because of the security layer, nobody wants to change that, blah, blah, blah. That part, yes, that's solid. That's just hardware. It's just no one's going to change that. Software always changes all the time. So I guess that's where you can jump into the whole aspect of layer 1, layer 2, whatever. Let's keep the base, and then other things, the other changeable things, which is the other layer after that can be changed. And then from a security standpoint or security vectors that are involved in there, that can be limited as long as the base is secured, etc., etc. But then from a valuation standpoint, Ethereum is good.
Okay. Yeah, no, of course. I mean, I think Bitcoin, a lot of its valuation, it's the narrative, it's the story, it's the principle of being the first. It hasn't had a major hack. Ethereum had the infamous DAO. Ethereum has already had a fork. But I suppose that what matters is the future, I suppose, like going forward. It'd be interesting to see how Ethereum evolves. For me, the transition from proof of work to proof of stake, that one I want to watch, because I'm a very skeptical guy of proof of stake. And I kind of feel like it's going to open up a can of worms. But it's also how they implement it. If they do this gradual process, like we see now with these proposals, obviously they'll argue it out, they'll run simulations, put it in a test net. And as with other proposals, when they notice stuff, they then roll it back, right? Before they allow it to go forward. So we might never ever see this proof of stake, hallelujah, 10,000x transactions for the next couple of years.
But then for the fees to go down, we need scalability. There's no other way. So however you scale Ethereum, that needs to happen. You can't get right now what's being the changes that have been made at the moment is not to lower the price at all. So for you to lower the price, you need scalability. You need your system to be able to scale.
Okay. Yeah, of course. That's
so.
Okay, cool. Yeah, I guess that's the holy grail of all things software, is that the economies of scale basically only make sense from that context.
But the nice thing about this thing is like Ethereum community, obviously others are a different one, but the Ethereum community, like if you just look at the proposals they made, or this one is essentially, you can see they're evolving. And then the sentiment from a price standpoint, people are liking that. That's why, okay, cool. Essentially, that's why the price went up after the proposal went live, right? The price went up because the sentiment is like, okay, great. But then in previous generations or with other blockchains, when something like this, which is sort of tangential to what the protocol was before, essentially the price goes down. So now you can see that the sentiment is looking forward to having Ethereum to scale. That's like one aspect of it that I got after this. I was like, oh, shucks, okay. Previously,
You see,
this
Bongs,
phenomenon wasn't happening.
you're entering into that realm of people trying to tie, obviously, the market price to something. All right. And obviously, one of the things is that
No, but then the market price that does actually indicate something. So for me, I'll
no, of
say it's
course,
the sentiments.
but then it just could be one variable amongst many, and it might not be the most dominant weighting in that.
100%.
But fair enough, it is a point. It is a point that at least it didn't go down, meaning pessimism in the change. So that's always
Yeah.
cool.
Because a lot of people are saying, people based on history, as I mentioned, when things fundamental changes happen in a project, there's a split, right? The same thing that we spoke about last time. When a measure happens, there's a split. So now that didn't happen. So what can we say about that? So a lot of people came in on board. What can we say about that?
No, it
What's the
means
one
that
thing that
it's
highlight about
Ethereum
that?
is kind of like has built a healthy functional ecosystem. Whilst we know the Bitcoin ecosystem, even till this day, so I don't even want to get into it, but like it's turned into some religious, kind of like dogmatic space where they obviously are hardcore believers who will not let Bitcoin be anything than what it was. And obviously, you've got the more flexible, you've got layer 2 that's coming up with Lightning. But yeah, enough about blockchain. All right, enough about blockchain. All right, I feel like
Cool.
it's kind of like it's progressing, and I suppose we'll have to see just how much more progress can be made this year in particular. But yeah, let's talk Google. All right, industrial robots and hardware. So one of the cool things that I picked up, I think about a week or two ago. So Google's had a division called Intrinsic, which focused specifically in the industrial robotics space. Now, obviously, you've got normal robotics for like consumer products, your little AI robots that can do fun stuff, and you've got industrial robots, which traditionally are your factories that are building cars and making food and building medicine, your conveyor belts, and all that stuff. Now, what's interesting about Google getting into the space is that obviously this is one of those spaces that is obviously locked up to traditional players. So you've got like your Siemens and all the likes. You've got your Airbnb and Airbnb. What does it sound like I'm saying Airbnb? That manufacturer slipping my head. All right. But basically you've got traditional players, all right, in that space. And what's exciting is to see Google basically trying to articulate this new world where we can basically have cheaper robotic solutions, both in terms of the software, the UX, etc., and essentially the cost themselves of basically setting up a robotic shop can go down, and the promise of flexibility and all the amazing things, big tech loves to promise when they get into a space. So what I love about it is that having been a little bit in that space professionally is to see a lot more of the innovation coming into that space. Obviously, bringing in the competition element, all right, which essentially will force some of these players like Siemens who don't ever need to innovate, like the same stack that they've had like 15 years ago, because they obviously are the dominant players in certain spaces. They don't need to make things better. They don't need to make things cheaper. They can keep things the way they are. And so having Google come in with the exciting toys, obviously throwing in a lot of money into the space, we could see a lot of interesting and exciting products. And it's something I'm really excited about. And I think what this means for, like, let's say you and I, or any typical, let's say, hardware focused kind of like founder or enthusiast, is that I'm predicting that depending on how much they progress here, we could see industrialization, aka the ability to produce like very complex and interesting stuff using automation at a smaller scale. So you can actually get a startup to build your own little customizable little shop that can, let's say, focus on building, let's say, a drone or a small little process that can, let's say, produce a small little miniature thing, as opposed to your big industries, which were basically the only guys who could produce some of these things at scale and obviously at an affordable price range. So that's pretty exciting. I think there's going to be a lot of enthusiasm there. And the last thing I'll mention here is
so
that
you continue.
Yes, the last cool thing that I see that they're doing is they basically bring in AI, not just in obviously the application layer in terms of being able to do image detection, etc., but also in the actual programming of the softwares. So one of the difficult things with industrial programming is a lot of the planning, mapping, etc. And so the engineering hours associated with, let's say, programming an entire shop to, let's say, manufacture a specific model at scale in an industrialized layer way, cutting out inefficiencies, etc., is a lot. And once you bring in AI into this thing, they're pulling out some really crazy numbers where they almost the example they use is they got a robot to program USBs in like 2 hours, whilst this could take like several. They didn't give a fixed number hours to do for like human beings. So that kind of stuff obviously raises eyebrows. Are we replacing the human beings with AI now? And obviously manufacturing is one of those spaces where the employment is pretty high. All right. And it's obviously technically one of the most critical infrastructures of any country is their manufacturing hub. And so, yeah, I'm excited about that. And I think it's something worth following.
So essentially, Google is coming in, as usual, coming into an industry that's sort of kind of been stagnant for a very long time. And then when they come in, they bring that element, the open source element. So they're going to be building tools in such a way, because that's normally what Google does, right? They don't just come in and build on what you have. They create their own space that they open up to developers or open up to this open source world. So you think something like that will happen here? Or are they going to play the same rules as pretty much the industry rules?
No, I think given how they've articulated it, all right, using words like trying to make it cheaper, more open, more equitable, and those kind of language indicates that they really do want to make a significant shift. So a practical example is this, like typically in like your industrial robotics technology stack, manufacturers basically have a monopoly on the stack. So you'd find that even being able to learn the IDEs, the languages, etc., you will not find them on Google. You have to get specialized training, for example, from Siemens on their specific robotics line in order for you to be able to operate there. So Google bringing in this open source kind of open environment will allow guys to basically come into the space. And obviously we've seen the benefits to some degree of open source. There's more diversity in ideas. There's more diversity in the problem spaces that people bring to the stack. And that itself obviously has certain effects. It means that someone thinking about the space today can't operate in that space unless they get into a traditional company, get the training, etc. But yeah, you and I can now start thinking, hey, how do I write an algorithm that can make a production line, twice as fast? And the code is on GitHub. I can mess around with it and I can contribute to that space, which is not possible today.
Then how do you foresee that impacting your normal enthusiast, that's the word, yes, and your startups and pretty much the little guy?
No, I think for the little guy, I mean, obviously there's the cost part. All right. Like obviously one of the great things, we'll maybe chat a bit about it later, about software is how easy it is to build and scale compared to when you get into the more hardware space where there's obviously physical infrastructure, there's things like manufacturing, there's logistics, and a lot of these hard constraints. What I like about this, specifically in terms of the costs, similarly to what we saw, let's say, in the smartphone space, where obviously once the big players got in, we saw the cost of basic components like cameras, certain sensors like IMUs, things that were traditionally very expensive like 10 years ago are like very cheap because of the fact that the big players have driven down the cost because of the economies of scale. So one of the exciting things here is that industrial robots are something that is almost untouchable by the average Joe unless they've worked in a company where they've received exposure to those systems. So that means that, you know, you and I, as an enthusiast, can start actually building stuff or even build a startup around that space using what we, obviously it's still very early to assume how Google will go about it, but how I imagine it happening is that the affordability will get to the point where you can build a industrial robotics automation company. And the business models will also be interesting to see how they evolve. I can see them obviously unlocking different customer use cases. All right. And I think the software part could also be interesting. Just seeing what they do with the technology stacks, because I have a feeling that knowing a little bit about the space, I mean, the IDs are old, the tools are old, you know, the user experiences are very, very old and rigid. So seeing how they build tools to allow guys to.
So in those enterprise space, because seems like that's where they're trying to get into. So obviously having this new shiny stuff is not, I'll say, suitable. Yeah, it's not suitable in terms of reliability, etc., etc. So also one of the major arguments of why things are not moving fast in these other industries like your health and whatnot is because of that. Because of now, we don't want things change, or banking and whatnot. We don't want things changing a lot because it's going to affect a lot of things. So do you think now Google coming in, creating all these new things, is it worth it or not?
Well,
why
I mean,
have we not been changing besides the cost element?
It's a good point. I mean, I think they obviously, like all things, it's never really like one specific thing. You know, it's kind of like multivariate. I think one of the natural instincts one can expect is that Google will obviously get into the space and will aim to both innovate, but at the same time try and obviously stick within the lines, aka the so-called move fast and break and apologize later mentality that we see with your other stacks that they've worked in, or the general big tech kind of habits that we've seen. Yeah, I'd see them like the best way I can describe it is David Sachs. So he's like the software as a service kind of like guru, and he obsesses with this new model, which is running away from the traditional enterprise model, which is about building this big, amazing product line and relying on enterprise contracts, essentially, which is what a lot of them do, to basically operate as a business model, versus what is seen as a consumer-first software as a service, where you bypass the CIO or the enterprise guy at the top, and you build the enthusiasm and the market base from the users and the customers from the bottom up, basically. And I see them kind of taking this kind of approach where a lot of this adoption will be the actual users, all right? The fact that I, as an engineer, when I discover that we can build cooler, better, faster stuff, cheaper, using a Google stack, and then start proposing that in my company and demonstrating, of course, the business value and all the like. So I think a key thing there is just competition. The fact that as a Siemens or any of these guys, Bombardier, whoever, building planes and all the likes, if Google can come in and provide a tool that is better, cheaper, faster, and obviously unlocks more market value from your customers at the end of the day, compared to your current providers, it's going to change things up. It'll obviously force them to also get on board and do some interesting stuff. So so to get back to your answer, I think that like I don't see Google moving and breaking fast here. I think this space is actually the margins between like the amounts of innovation that can happen without breaking much is pretty like wide, meaning the space is very ripe for innovation and disruption. and still do it within the margins of what's possible. All right. And a lot of what kept a lot of the traditional players out is things like just capital. I mean, these robots are damn expensive. And seeing a Google obviously having the deep pockets, that they can obviously get smart engineers to build things at this layer could be interesting. And this is obviously in contrast to, let's say, a company. I keep bashing Siemens. I feel like I should find another one. But they're like the biggest player. Like Siemens might not have the revenues to invest in deep tech R&D into the space, and Google does. And I think for all the critique we have of big tech, this is one of the things I actually love the most about Google, is that they invest a lot of money in solving difficult problems. All right. And I think that we saw that with what they did with essentially the whole biology database they released, where they basically use machine learning to map out different protein structures. And
while we're on that machine learning thing, you did touch on this Intrinsic project essentially introduces AI to make things better, performance and everything else. Do you actually think it's needed? If it is needed, which is that question of AI versus a normal way of doing things. And then we know that almost like 90% of all the startups that are machine learning, they're actually doing if statements.
If else statements.
So there's that element. And then how does that work? Do you think that's actually needed?
It's a complex question because you have to bring.
Let me add on that. So if you think it's needed, then for a normal job, how do they now use it, right? Or how do they utilize that? Because we know for machine learning to actually be more effective, you need a lot of data. Google can do it because they have a lot of data. Great, but the normal small company, they can't afford to do that. Yeah, sure, Google can outsource that kind of thing, which is currently one of the product lines. It actually does that, right? They probably might in the future create a Google for manufacturing, where there's an API there where you connect to it and use it for those kind of stuff.
Yeah, no, I mean it's an interesting problem, and in your language, I'll maybe get to the fundamentals. I think we need to focus on what exactly is the problem that's being, let's say, solved here. All right. So the big thing here is you're dealing with manufacturing. So you've got this issue of more human beings needing food. And so you want to produce things at scale, cheaper and faster. So if you take something like COVID and vaccines, so you're in a situation where you want to mass produce vaccines at a cheaper, faster for something critical like saving lives. So a bit more context in manufacturing, where something like just an hour of downtime can equate to millions in terms of revenues and obviously costs and stuff like that for the company. So you have this issue of basically trying to make things better and faster, with the end users, obviously you and I. Now, there's the technology element of it. Is it okay to get AI to just program things faster so that at the end result, we can basically get cheaper products or cheaper vaccines, et cetera, et cetera? That's one of the tricky things about this AI automation kind of problem. For the end user, me, at the end of the manufacturing line, at the customer, that's great and that's amazing for me. But as, let's say, a worker, let's say, who spent years, which is quite typical for these spaces, where someone will be a robot programmer locked into their ecosystem and their stack and will do that for years, that's not great, because obviously you're being automated out. And the natural answer is the typical nonsensical, well, they must just learn to code better or figure out some other way or go painting or something like that. And the robots are basically shifting them and releasing them to do better stuff. But this is where kind of regulation does come in, like where in South Africa, for example, you'll have some laws, don't quote me on this, where you find that some factories can only automate up to 60%. All right. So even without talking about the robot programming themselves being automated, just automation in general is a force that needs to be regulated in order to balance out this equation of labor versus, like, obviously technology. So I think generally it's a good thing because it'll allow more players to get into the industry. And it also depends what Google does. Are they going to become an OEM, i.e. an original equipment manufacturer, where they're going to create different industrial robot product lines that we can buy? Or are they just going to build more of the soft layer, the stacks, and then we can just use the tools so that existing OEMs can basically just take Google stuff and build better products for their customers? So is Google themselves going to be a competitor to Siemens, creating new product lines to compete with Siemens robots? Or are they going to be building tools such that Siemens themselves can basically use and incorporate? So it's also not clear.
We know Google have done it 10 million times. We know what's their path. The initial path is like that one of saying, okay, great. We're just going to give you guys the software and then you guys have control over everything. And then in the future, and then they flip everything and then they become a competitor.
And one of the indications of that is that they've basically created a new division. So it means they are quite serious in obviously it becoming something a lot more mature than just a source of tools and stuff like that. But I mean, like, yeah, so to get back to your question, yeah?
The question, so there was two. So the other question was ML. With ML, can anybody afford it? And then is it worth it?
I think that in principle, yes, because we've seen the results that from a sheer, let's say, performance perspective, ML in certain industries and contexts has validated that it's worth it. It's great. And everything that you can say that's negative about the cost validates for me why I like a Google doing this, because they have the money to put into the space. And what I love about what they do is obviously using their dominance, they basically are able to make things essentially free and cheap. But as we know, they have a backdoor element to it, which is make everything free and cheap, but at the same time, they'll, let's say, capitalize on analytics, advertising, et cetera, et cetera. So, yeah, so I think to get back to your question, whether it's cheap, obviously for you and I to sit and do R&D on new algorithms to optimize the manufacturing process is not cheap. You and I can't get into it. But that's what's great about Google doing it, because they can get in and solve a lot of the critical issues there and obviously provide the bottom line values for you and I to basically jump on and build special purpose, let's say, businesses or startups that can benefit from that. So that's obviously the one side of it. And obviously a lot of this depends on how Google wants to go about doing this. All right. Will they lock it up and make it, because of the way the market is at for these products, they might not decide to do the hallelujah free stuff model. They might actually make it premium and maybe might get into the same business and realize that if an Alstom is willing to pay $1 million a year for licensing for some software, why should we come in and make it free? We can maybe make it slightly cheaper and offer more value. All right. So it might not even be something that gets into like the everyday consumer, but from their language, once you see the word equitable and free for the average guy, it feels like they want to basically bring the same revolution we're having in other layers of the technology stack, like mobile apps and the cloud, etc., and unlock that same kind of dynamics in the industrial robotics space. So that means, we start to see more players doing GitHub commits for some new process, or even in the hardware space, which is what I'm excited about, is seeing a lot more of these systems open up. All right, where let's say I might, maybe Google might not get there, but we might get into space where you can build a startup to build a new industrial robot. All right, that can obviously get all the Google elements to it and use that as a mechanisms to access the market. Whilst today, if I try to do that, the technology stack is so heavy that I might just build a robot, but all the different, especially at an enterprise level, all right, the certifications, all that stuff, they might do the heavy lifting so that I can just bring in their Google, robotics SDK, and then that handles a lot of the stuff that a startup can't deal with. So from a cost perspective, again, it definitely makes it cheaper for guys to, let's say, innovate and play with. And even for like medium scale companies, which is probably where I think a lot of the action will happen, it will make it a lot more interesting for more competition in that space. And yeah, I feel like I'm being a Google evangelist now. All right.
So I was about to ask that. So you're happy with Google jumping in any industry and making it better?
Definitely not any industry. I think like we'd have to look at examples, because obviously let's maybe bring the drawbacks of it. We know that Google has had a habit of just dropping product lines, Google Plus, the Google Glasses. So there's so many things that they've started and stopped. But what I'd say is, if you look at some of those things, they're kind of like, they're not necessarily as, for lack of a better word, serious as getting into something like industrial robotics and stuff like that. But I could be wrong. I mean, because I know they did have
they do have that thing, the robotics group, the one that did Datadog. They bought that. What do they call them?
Boston Dynamics.
Yes.
All right. So they're still around. So they've got these divisions, but so that's a drawback, is that they can drop the whole project essentially. Another drawback, of course, is you don't want to see the same dark move fast and break tactics. It's one thing to be spied on your smartphone and have all these crazy aggressive data mining that's feeding into some advertising model. It's another thing to have that in your car, or to have your critical infrastructure designing or building vaccines being run by a company that's heavily trying to use some kind of data there for advertising, and feed into these very nefarious business models, which maybe don't fit well for very critical infrastructure. All right. So that's kind of like where you kind of like frown on, is like, but we know that Google does build other products. They do build stuff for the military. They do build stuff for like other healthcare kind of like critical systems. So the mode of operation for Google here might be very different than what we know Google is, which is your Google search and all the issues we are seeing with it. And I think for me, basically the principle is that I love Google when they take difficult problems, particularly deep tech problems, and they put a lot of money into it and they unlock value. That's where Google is amazing. But maybe in other contexts where Google starts to outcompete players, for example, we know in search, where you'd have, let's say, booking.com that is typically, let's say, doing hotel booking. And then Google comes into that space and starts to build their own product and basically drives them out of the market. Those are probably the spaces where obviously Google and all the others like Amazon are very, very predatorial and are obviously full of shit, for lack of a better word. But when I see Google get into these kind of critical spaces where they are tackling difficult problems that other companies don't have the money, infrastructure, or the engineers to actually do it, that's amazing. I think that's the perfect use case for why we have big tech billionaire companies, is they can do these things that others can't.
Okay. Yeah, cool. Let's see how the project goes. Hopefully nice things pops up out of the whole situation, where we're getting new tools from it, new protocols. That would be lovely. As usual, I love tools to play with. So let's see how it goes. Let's get into a new topic.
Yeah, so I think a topic I wanted us to chat about, which is always an interesting one, is the difference between building a software-focused startup or business versus a hardware startup. All right, and even though we say hardware, we know that this hardware involves hardware and software. So you can almost have that compounded relationship. And what are the challenges with basically building those startups? Why are we seeing software startups basically get more VC funding, scale faster, and why we're not seeing as much hardware startups? The failure rates in hardware startups are higher. And in general, even just from a market perspective, hardware engineers or electronic engineers are priced, are valued less than, for example, a mobile developer. So why do we have this disconnect between the hardware and the software space?
Okay, so on your side, what do you think? Don't be general. Be specific in terms of your experiences.
Okay, I think that like from my experience, like one of the exciting projects I worked on was building a new medical device. So we're trying to basically take your traditional stethoscope, bring in some exciting electronics so that we can digitize the, you're shaking your head. But yeah, so basically we obviously
yes, because IP and shit.
Yes, there's IP elements. That means that we weren't infringing on IP. We discovered actually a lot of the different patents that exist.
But you right now, are you not infringing on the IP?
Well, not so much, because I'd say that typically it's not new. All right, there's actually quite a few players in the space who try to do this digitization essentially of stethoscope sound signals, sending it to a mobile app, etc. We'll edit the segment.
Then the more you talk, the more specific you become.
The thing is, you asked me to be specific, so my brain went on this. Okay, let's dive into it. But
yeah,
we'll edit
specific in a general way.
Okay.
Specific without adding IP elements and the specific how that thing was built.
Okay, cool. Long story short, we'll edit out whatever elements. I think. All right, and hopefully, we don't. I don't infringe on the startup. But long story short is basically digitize the stethoscope, get data, send it to an app, and obviously you've got the data elements to it, machine learning, etc., that we wanted to bring in. And the first thing you encounter is the cost of just getting a prototype. All right. Yeah. Meaning you actually have to go buy hardware. You have to go through data sheets and basically analyze the problem from the physics all the way up to obviously the software elements that you can extract. So the design debt is pretty high already compared to, let's say, building an app. And
but then the design element, which is high, I'll argue that it's the fun part, isn't it?
No, of course.
It's what you've I say, okay, some people might say no, but then it's why you went to school, to acquire this knowledge so that you can sit down and design hardware. So you can do that. That's not the problem here.
Yeah, or but you see now that's where it gets interesting, because now when you ask the question of why does the one scale faster and succeed versus the other one fail more and is slower. And one of the reasons is that it's a lot harder to basically design hardware. For example, I'll use a practical example. If you want to build...
It takes... Is it harder in what sense? Does it take longer to fully design something, or is it just hard to think about the actual problem?
Okay, I think there's a key part, I think, that makes it hard, is that it requires a lot more first principles thinking, which typically means that you invest a lot more in validating a lot of assumptions before moving on to the next phase, as opposed to what? As opposed to, let's say, if I want to build a mobile app that, let's say, tracks location. There's a gazillion examples of that on the web. If you're in a startup, there's a gazillion libraries you can use. Google, which you just spoke about, has amazing things built for you. So you just come in, plug. You don't have to think on a first principles layer of how to solve that problem. And you can focus on where your business value lies.
But then don't you have right now with the whole where the world is right now, don't you have things that you can buy and plug?
No, of course. And let's say if you take, for example, the medical problem you're trying to solve, and specifically because you're trying to, let's say, be low cost, low power, and giving all the business high elements you're trying to target. So if I throw enough money, I can put together something that kind of works-ish. But I'm trying to now get the cheapest, and I'm trying to innovate at the layer of how do I get better quality signals, and how do I remember one of the problems I try to focus a lot on is synchronizing audio signals between a phone and an app in the fastest and most efficient way. You will not find a lot of code online to help you with that. So I had to go down to the basics of the Bluetooth protocol, understand the limitations of the actual network link itself. At what layer can I make a difference to make this thing a little bit better? Whilst, let's say, if I'm in a different problem spaces, there's a lot more minds have been involved solving this. So I can come in and just plug it in and focus on the next layer of the problem. So I think with hardware, you've got this issue of it being hard.
I'm still trying to get what's hard, because every element you're touching on, there's the equivalent in software. What makes hardware different?
The difference is that with software, there's a lot more problems that have been solved. So the hard part essentially is that when you get into this problem where I need X, I need to come up with it from the ground up myself versus relying on something that's already existing. And so if you look at it from a comparison journey, someone's running the software marathon, someone's running the hardware marathon. More often than not, someone running the software marathon, obviously, depending on what problem they're solving, X, Y, and Z, they are more inclined to have more support in terms of frameworks, libraries, tools, kits, etc.
Let's take blockchain, for example. Blockchain came on board. When it came on board, there was essentially no support whatsoever. When you pretty much trying to build something in that space, you're essentially going back to the basics of what things are and how things shucks, I'm stuck again. Can you hear me?
Yeah, you are stuck. So let's see. Let's see how we can just try turn your video on and off.
Yeah, it's connecting. It's connecting.
Okay, cool.
Connecting. Okay, I'll just talk. Yes, so you get to, because why I'm giving you this example, you mentioned that hardware is more fundamental based, right? Where in hardware, in software, you get a lot of support. There's a lot of spaces which are new. That's why I'm touching on the blockchain space, for example, where when we're building something there, let's say three years ago, building something was hard because you go back to literally the basics. You don't have any API you can use. There's no libraries you can use. If there's a library, it's old and those kind of stuff. So whatever you use there, you need to come from a blockchain fundamental perspective, right? Same thing with the hardware. So what's the essential difference? Is it because it takes longer to get to your solution because it's software or hardware, or like what's the major difference? And it don't highlight that it's fundamental based.
Okay, cool. So the first key part, you make a good point, which is that you can get the same kinds of problems in the software space too. So the first thing to highlight is how often you get it. So for example, in the technology, in the software space, all right, if you look at the spectrum of the different products or things people build, from DevOps to mobile to backend to frontend, etc., more often than not, people building in that space are less likely to have to think from a fundamentals perspective, because there's an ecosystem around it to basically make it thrive. And obviously less people have played in the hardware space, so the ecosystem is not as rich. So the key thing is about obviously things like speed, so the pace at which, so let's say you remove the fundamentals element and you assume it's inherent to any engineering problem, all right, the pace at which you can go is obviously slower, all right, and then you also have this.
What makes it slower? Let's start there. What makes it slower?
So a key thing that will make you slower is obviously the fact that you actually, and obviously we're talking, because you need to get into the product life cycle, all right, from conception to, let's say, going to production, all right. The first comment I'll make is typically in your IoT kind of use case today, you don't just have the same problems, let's say with software, you have hardware and software that you're kind of building generally at the same time. So that already means you're going to take longer, all right, inherently. So if I want to build some smart meter solution, I've got to build the firmware, get the hardware, get the sensors, everything. Then I've got to build the app that's going to connect to it. And I've got to build the database, the cloud services, all that stuff. So already that means that you're going to take longer building an IoT kind of hardware project as opposed to a software only project. Then there's obviously the basic issue of when you go beyond that MVP, let's say prototype kind of stage, and you now want to get into the business of basically scaling, where you want to go from, let's say, 100 users to 1 million users. With software, it's easy. Once you've got an app, okay, not easy, but once you've got an app deployed, your scaling typically involves, more, let's say, vertical or horizontal integrations on the servers. And with things like, for example, AWS and Google, some of the stuff has actually become a lot easier for guys to do. As compared to, let's say, a hardware product where, let's say, you've got some device like an Apple Watch, you basically have to include a lot of other disciplines like logistics, mechanical engineering, there's the electronics aspect of it, there's the manufacturing aspect of it. And so obviously that adds more weight to the kind of teams you need to build. So in a software team, you typically maybe would have your developers, maybe a product manager, and obviously you need some kind of like business developer, CEO, CTO, the typical stuff. Whilst in a hardware kind of team, on top of your software engineers, you need your mechanical engineers. You need someone who specializes in manufacturing, and you need someone who maybe specializes in distribution and logistics and all these other elements. So that obviously means you need more money.
Essentially, there's in hardware, there's too many moving parts.
Yeah, that's another way of summarizing it. Yeah.
But then for now, let's remove software and focus only on hardware. Because that's what we're doing in software. We're removing hardware. If you remove hardware and if you remove software on your world and only specifically focus on hardware, how is it difficult to scale hardware?
Yeah, so I think there's many ways to attack this question.
Yeah, so I'm making assumptions that you're buying or you're building software, you're building hardware, and then the software layer to
abstracting that.
Yes, pretty much to make sure everything it's very simple, so that we all on the same page. That one is let's say you what do you call it? You just outsourcing it to somebody. Okay. You as a company, as a startup, your only layer that you're focusing on is hardware. How is that different? How is that difficult compared to somebody who's purely focusing on software?
Okay, cool. All right. So I think the most simplest example I can use is for somebody to, let's say, have your new software in their hand. They, let's say, need to go to the App Store and download the app, and you've got a new user. All right. Now, for somebody to, let's say, get your new Apple Watch in their hands, all right, and mind you, you've coded the app once and it's deployed. So you do zero work for you to go from one user who didn't have your app to a new user who has it just by going on the Play Store. So basically, the amount of work done to adopt a new user on the software is almost nothing. All right. Obviously, we know in the back end, there's scalability, there's handling more stuff. Forget about that. Whilst the hardware product, you basically enter the world of atoms, where somebody obviously needs to manufacture this watch. And obviously, you need to now get into the realm of dealing with suppliers. So typically in hardware, it's almost unlikely, or it never happens, that as a hardware company, you build everything in-house from scratch. Chances are you'll find that the strap, I need to go to a specific manufacturer that just does the strap. I need to go to a specific manufacturer that would, let's say, just focus on
No. Let's pause there, please. Let's pause there. So I want to just make everything very concise. So you on the software layer, you focused on this thing was built and then it was put somewhere, then the distribution was seamless.
Yeah, it
You
can
don't
be
get
copied.
involved, right?
All right.
Yes. Now let's get to the same model on the hardware side. You've built it, you've built this one thing, and then how is the distribution difficult?
Okay, cool. That's a good point. So taking into account that the product is built,
Yes.
how is it distributed? So I think the first key thing is just looking at distribution itself. There's something physical that has to go from a warehouse where it's being stored into the hands of an actual customer. So that means that, I've kind of lost you there.
Continue.
Yes, that means that there's that layer already there that basically needs to be accounted for. All right. So obviously that means the cost of actually shipping it, etc. Then you also deal with the fact that when you need to make changes to a specific issue. So for example, if something crashes on your app and you get a bug report, you can basically release a new version, deploy it on the App Store.
That's another element. That's another element, which is maintainability, which we can jump into. But then let's focus on this one bit and finish it to the fullest, which is you said what not scalability, but then yes, distribution.
Yeah.
So software, I deploy my software, everybody can use it right now. Boom, nice. Hardware, I built it. Now I have to obviously communicate with, like, for me to build more. How is that difficult? Is it because now I have to, like, there's money towards that, or like how is that different?
Yeah, so you've got so the main part I mentioned is obviously the distribution part. But if you talk about building more, there's the manufacturing process.
Yeah, because that's the distribution, right? That's the distribution part you're talking about. Software is just there. Distribution happens, it scales on its own. Hardware, it's there. One of it is there. But now to get more people, you essentially need to create more. But then you've already built it and designed it. The main part is getting more of it. How is that difficult versus software?
So the difficult part is the making part, like you highlight, the manufacturing part, the fact that you basically need to create this thing to match the demand. All right. So that means that it needs to go through a process of, like I was alluding to, the multiple suppliers that you need to coordinate to basically get to this new product. And so obviously things like having to retest, revalidate, all right, stress testing, all that stuff. And if you look at it realistically, in the example today where everyone's making things in China, you have this problem that you've got a warehouse in China that is basically making all your watches, and in an ideal world, testing them, packaging them, and sending them to your customer. So that whole process itself involves a lot of moving parts, like you alluded to. And there's obviously the cost itself of making it. So with software, I've made it once and I can copy it without cost. Whilst with hardware, I actually have to spend something to make another one. All right. And that already tells you that the margins in terms of profits are also a little bit tricky, because obviously I spend zero to get a new customer. So that's almost 100% benefit you're getting from the initial work you've done. Whilst with hardware, you're always spending to get something. All right. And that obviously means that the capital costs for a business are obviously not those graphs are not going to look the same. And that's obviously feeds into why you maybe have more VC funding for software, in the sense that the phenomena of going for the so-called hockey stick distribution in terms of scaling, where they can go from like 100x to 1000x, it's almost seamless because the cost of software and growth is almost like nothing. Whilst with hardware, you're always spending to get more. And so the returns for a VC is not as great. And you'll find that what's interesting with hardware is almost all of them today don't make money from the hardware itself. But the game has been to basically introduce a software layer, which typically involves some form of subscription, which is where they're trying to get the kind of scalability that they're seeing in the software world, and using the hardware as almost like an ecosystem peg. Obviously, the best example of that is Apple, of course. All right. And and how they roll with their whole gated ecosystem. So yeah, I mean, and so that's obviously like the biggest difference, I guess, between scaling software and hardware.
Okay. So let me give you my my use case. So in my use case, let's say it's similar to yours, but then yours obviously is heavily hardware. Mine is heavily software with a hardware element, where you essentially building you're selling a software solution, but then to distribute it, you need hardware, right? So we are, I guess we'll say we are a software company, but then to distribute our product, we actually need a certain hardware, which we just, I'll say, whichever model you want to use, you can lease a certain hardware product, you can buy your hardware product, you own it, and then you just lease it to your clients. That's where we are from my perspective, from my side. Now, the issue obviously becomes, as you mentioned, you have software which you've built. Now to distribute it becomes a mission. You're actually dependent on this hardware. This hardware is expensive, right? Okay. So to buy a lot of it upfront to get to clients, it becomes a challenge. So now you can't just buy, let's say, 100 of them, and then when clients come, obviously you now just distribute, and obviously hopefully you like based on your calculation, you can recover that cost from that client maybe in a space of 6 months, for example. So that's my use case. So now you have this thing. Obviously, if you buy a lot of them in upfront, that money comes from you. It's money that you as a company have to now chip in on. But then you have that depending where you are, startup, whatever the case may be. If you don't have enough a big budget for that, it becomes a problem on how you scale, because you're dependent on this thing. If you buy it, let's say 6,000 rand just to buy one, and then now if you now 6,000 multiply by 10, that's already 60K.
Yeah.
Then in South African context, 60K, yeah, that's
a startup.
A lot.
That's pretty heavy. Yeah.
Yes, that you can do a lot with, right? So for this kind of startup, maybe, but then for your side of things, which is, let's say, the medical side of things, it might be nothing. You probably might need maybe 200K to actually build one, for example. But then where we stand, it's a lot. And then now you need to look at how do you scale this thing. So the only way to scale it is bit by bit, which is a slow incremental scale, or get VC funding, boom, bam, and then you can now buy a lot and scale much faster. So you're essentially focusing a lot of your money on devices.
Yeah, and obviously VCs, you're not as attractive to VCs because you're not as sexy from a numbers game compared to a software company. So VCs typically will then be very picky on which players that they're willing to fund. And maybe we can chat about how that is slightly changing to some degree, all right, where there are certain trends that do provoke a lot more, let's say, funding and economies of scale to get into hardware space. So, for example, we've seen like the smartphone space, which we always talk about, how having more smartphones have basically made something like cameras cheaper, which then means secondary markets.
Yeah.
Where if you're trying to build a product that involves a camera in your startup, you benefit from that phenomena, and thus obviously the cost of your devices, etc., go down, and thus you can play around with more, take more risk, etc., etc. Another one was, let's say, what we saw with Bitcoin and the whole Bitcoin mining euphoria, which basically provoked a whole ecosystem around developing what they called ASICs, your application-specific chips, which basically were optimized purely for mining. So if you look at that space as a startup trying to build anything along the lines of mining, you basically have an economies of scale that has actually made products or chips essentially cheaper in that space. So we do see how trends, and I think maybe one last one worth mentioning is the whole new trend we're seeing with what is called machine learning on the edge, or edge computing, or AI on the edge, which basically involves taking the traditional heavy lifting that was happening on the cloud and bringing it to the device. And obviously the key benefits there are the user experience, more responsive, etc. And obviously a hot one is privacy, all right? Being able to keep devices, keep data on the devices, all right, and still be able to do all the amazing magic locally. So that kind of hype obviously means, like, today, if I want to build a AI, let's say, startup that has hardware and software, today it's obviously a lot easier, cheaper than what it was, let's say, 5 years ago, all right, where there wasn't as much hype. And so that means that even the big manufacturers, like, will be making more dev boards around that use case. And obviously an exciting thing I always keep an eye on is China. The fact that they've become pretty bullish on these type of use cases. Every day we're discovering some new Chinese hardware or Chinese chip that's better, that's faster, that's cheaper. And unlike 5 years ago, where if you found a Chinese chip, the data sheet is in Chinese, you can't really understand anything. These days, I mean, they're pretty mature, all right? You find that the quality of the documentation is spectacular. The general user experience has gotten better with dealing with some of these mystical chips. So I think that for me is a positive trend, all right? But the fundamentals have not changed. That vis-a-vis software and its ability to scale, you still have hardware that can't scale as much. So if you take your space and time complexity analogy that you have with software, where it's about the order of magnitude as opposed to the nitty-gritty, let's say, constants, or the things you're multiplying in front of the core variables, I don't think that's changed. So that means from a general startup scale perspective, you'll still have the same graph in terms of scaling software and hardware. And the key question I'd maybe put at you is, how would that change? What would make that different? Or is it just something inherent to the fact that you've got the world of bits, which is digital, and copy and paste happens in 1 second, and you've got the world of atoms, which is physical and will always involve a certain amount of energy to put into scale?
Essentially, that question is, how do I fix my current problem? How do I make the business more scalable? I mean, like, when will that change, or how will that change? Yeah, that's a tough one, right? Because I'm thinking, if we only focus on, obviously there's different models that you can play with, but then if you only focus on the hardware bit, isn't what's the major problem here? The major problem is the price, right? It's the price. No, it's the price, and it's, I guess,
it has to be made.
Besides, it has to be made. No, that's not much of a problem. It's the price, and then the other element of it is consistency, right? So if I'm buying from a certain manufacturer, am I guaranteed to get the same product over and over? Because my experience is that almost every 6 months or so, we get a new product, right? Or a new device that we have to work with. That obviously, yes, you can minimize it by if you're big, but then we are a startup. If you're at a startup, you're pretty much getting, you don't have, I guess, power, scale-wise, to go and negotiate with those people of saying, hey, I have 1,000 devices that I can make an order on, so can you keep this device for me for let's say 3 years? I know it's guaranteed, it will work for me, I love it. So now we have to remove that element. We now, as a company, needs to always be able, like, we need to create software in such a way that we don't care which device we land on. It just needs to work all the time. So that's the problem. That's where we are. But then obviously it's not guaranteed. So you come in and then you get an OS that something else doesn't work on that device. You have to now tweak a few things to make sure your software works on that.
Yeah, can I push back a bit on the having to make it is the problem? Because if I listen carefully, you can correct me. The issue of consistency, I see it as a subset of the fact that you constantly have to remake it, which means that you have something new that needs to be made and validated. And on top of that, you've got this problem, like in your case as a startup, you don't have the volumes high enough to make it economically viable for a manufacturer to, let's say, keep making your stuff in 5 years or keep 1,000 of them in store. All right.
Yep.
So so consistency is one of the subsets of the fact that you always have to make it, aka you always have to manufacture the new product.
Consistency matters from our business perspective, from the manufacturer, the owner of those things.
Yeah.
Yes, that's where your point then comes in. From me, I care about consistency, right? And then from them, they care about building it all the time. Then what keeps them building it? I only care about, okay, is it there? If it's not there, can I find something that I can use that's similar and then doesn't give me a lot of problems?
But I guess this highlights another complexity. There's an element of it in software too, but for example, let's say in my context, I'm thinking as an OEM, as a startup trying to build an original equipment and manufacture.
Oh yeah, no.
That's obviously I'm reasoning it. Now, obviously, you're more of a consumer, so you're thinking more about the supply chain aspects. But as you can imagine, there's a chain reaction. As we're seeing with the chip manufacturing crisis that's happening right now, in as much as you might not be an OEM, or if I can unpack it a bit, what happened is because of COVID, basically the supply went down. All right. Yeah. And even before COVID, there was a bit of a mismatch. So the guys turned off the factories. All right. So that means this big machine that's creating billions and billions of chips at an economically viable rate that keeps the market where it is went down. And then now, obviously, you realize, shit, we need to turn the machines back on. But obviously, the market, basically, there's a mismatch between your manufacturing, for lack of a better word, graph.
Yeah, so for me now as a company, where I stand, if that's happening, I don't really care much. That can happen all the time. I'm now in a position where whatever the market does, I need to find a device that I can use for my business. That's where I'm at. The market can go up and down. I don't care.
But
as long as there's some kind of supply, some way.
Oh no, of course. But
I need to be able to jump in.
Those things will present themselves to you in different kinds of. So you won't have like a manufacturing problem, but you'll have a problem that I need to change devices, or you'll have a problem that my software needs to now be reprogrammed for this other device. So obviously you're at the end point. Obviously you're, like you said, you're software first, but depending on hardware. So what that means, again, coming back to our original thesis, is this question of now trying to scale and go bigger, faster. You have a lot more curveballs that can come at you than a software company that maybe might not even have to factor in these kinds of problems. And I guess it comes back to that question of like, how does one fix it? Like, will the fact that,
but then even before we fix it, like, obviously I gave you my use case, but then if you think about other elements to it, you have I'll say an Apple, right? An Apple, they're big, and let's forget about that they're big. Let's just focus on the element of they are like so integrated with their hardware that it's just beautiful. It works beautifully, right? Forget about the manufacturing and everything else around it.
FYI, supply chain. Google's joined the party.
Yes. Yes, they have. Yes, they have. So if you have those kind of stuff, the big advantage of that is that your software works efficiently within that chip, that device, whatever thing that you've built on. If you do control the supply chain and everything else around it, great. If you're dependent on somebody else, just make sure you can control them. Google, they're good, they're big. Apple, they're good, they're big. They can, like, they have the power to fight against those people to guarantee that they will have this amount of chips at a certain time. While where we stand, we don't have that control. We just going with the flow. The only thing we can control from a scalability standpoint is making sure that our software can run on anything that comes our way. Okay, so that's where we are.
Here's a thing I want to throw at you, and I'll use the phenomena that are happening in the industry. So you brought up price and the things you can't control. All right, let's take those two things. Now, even if price went to zero, you still would not be better than a software company because there's things you can't control. So even if the device went to like R1, where it was negligible, you still have this factor to take into account. At what point?
But that's the same. That's the same on the software world. If you have a software, those phenomena can come. Let's say Google dies, then you can't distribute your product.
I agree with you. The issue of something I'm relying on breaks, therefore my product breaks. I'd still argue that you're a lot more prone to it in hardware because it actually happens more often. Almost every year you hear iPhones, there's a shortage of this, there's a shortage of that. So you find the software is a lot more robust on average, all right, for certain kinds of problems, all right? And because they can iterate, move faster, so things are improved much quicker. So coming back to this question, that let's assume that even if price of the device went to zero, you still have this ecosystem of dependencies which still make your startup difficult to scale, all right? Because even though you are not building the device, the other guy has to build it, and there's constraints on that. Now, then there's the other solution to this, which is what we see Apple and essentially Google doing. AKA, they've then decided that instead of me relying on Qualcomm or Intel to make the chips, where Intel can decide to start making shitty chips, which then makes my end product not so great, let me in-house that and make that on my own. So basically, the logic, obviously, if you remove cost and let's say there was just an initial cost to pay, wouldn't it make sense that you actually start making your own devices? Then you start having, obviously it sounds crazy for a startup, by the way, but let's say—
No, it doesn't. I want to finish your thought. I want to jump back to your original question.
Yeah, so if basically in terms of solving one, meaning there's the cost going down, and then there's obviously the things you can't control. So naturally it means let me try and control as much as possible. All right. And that's what we see companies with big capital going. So you start off small with little control, but as you grow and grow, you see a tendency for companies to try and bring everything within their ecosystem. All right. So then from a startup perspective, in your case, is it too early for you to start thinking about how you can get more control over your hardware? At what point would it start making sense for you to say, okay, Bongs, you're a mechatronics engineer. You can get an LCD display. Can't you build a little a piece of hardware that can basically do what the other guys are doing? And then you start having more control.
Yes, so the answer is already there, right? We've already spoke about it before in the session. The answer is, ideally you want to do that because you can control. But then if you look at the cost of actually you manufacturing that thing on your own and then making sure that everything it's in order, hardware-wise, is not worth it. It's more than just getting a normal device on the market right now at any time. But then if I build it myself, the whole it adds probably 3 more other layers, or 4, 10 layers on top of that. I have to design it. Cool, that's not a problem. I've decided it works. Now, to manufacture a lot of them, I need to have a relationship with these people, with these manufacturers. Now, these manufacturers, for them to actually build it, because again, we are a startup, our volumes are low relative to the typical clients that they work with, we're not worth it. So that means the chips and everything else that they essentially buying to us or selling to us, they will be way expensive relative to like people who buying in bulk. So you might manufacturing it yourself, it's becomes way expensive than just buying what's on the market.
And okay, cool. Like I mentioned, that was obviously not ideal for a startup, but I guess the idea was more the trend towards, to the degree that you can, you start to get more control. Obviously, you'll never have complete control because even the M1 chip has an ARM processor on it. So they still rely on ARM, the latest whatever chip, to feed into their own pipeline. But the point more was the trend, all right? And obviously, like we mentioned, this is what I love.
The trend that, like you highlighted, the trend highly depend on how big you are, not how big you are, but then how can you communicate and talk to those guys, right? The people actually building for you, right? So if you have, how do you control them? Like with any situation, you can control them because you have volume. You can control them because you have a lot of money. You can control them because you are dating their daughter, or you're controlling them because the CEO is your girlfriend or your wife. Then the price is going down, bro. There's many ways of controlling people. But right now, as we stand, just money wise, we're not big enough to control.
Well, I guess control, obviously there's controlling them, and then there's you gaining control to some degree. So if you're to, let's say, draw like a pie chart, all right, and you bring your set theory. So there's a sample space of things that are your business. And then obviously gradually you want to obviously make your pie bigger in terms of what you can control and versus the things you can't control. So obviously what's interesting for me, which is what I want to tie into this question, is given the trends that are happening now, AKA devices getting cheaper, AKA Google going into robotics automation to try and make things cheaper for like a startup, AKA China, and obviously the cost of manufacturing obviously getting a little bit cheaper. And even with China, knowing that we have to become a little bit more...
Things get cheaper, but then the software layer doesn't get cheaper. It gets shittier.
Well, okay, obviously that's... how do you quantify that? How do you characterize that? Like, when you say shittier, what do you mean? Like, we're getting more bugs in our apps, we're having more crashes in production. Like, how would you classify software as getting more shittier?
Okay, so 3 years, let's say 3 years ago, you'll buy hardware. Obviously, it comes with its own operating system, whatever. But then as we go along, still same price, you say, but then the software itself just gets shittier because it doesn't, I don't know whether it's not communicating well with the hardware layer or what, but then it's not like cheaper price, better, I guess, what do you call this thing? Better experience from my perspective. I haven't seen that. Every time you're on that lower spectrum, you're always dealing with shitty operating system. Like operating system, communication between operating system and the OS. Regardless how over the past 3 years, how things get better.
Okay, well, so you say it's that hardware software link that's getting shittier. I suppose that I'll push back. I'd say that obviously this happens because at any spectrum of the market, you find for everything, there's the cheap version of it, where if you're focused on price and you're willing to deal with the shitty software. There's the other version that obviously is better quality. So you've got a spectrum of different products in the marketplace that are always meeting different consumers. Now, my argument is overall, the trend of the market has been that we are getting things that were more expensive, like 3-4 years ago. We're getting them at a cheaper price, even right now. So you take, for example, even like just look at processing speed, all right, on average, all right? The amount that you would pay for like a 100 megahertz MCU microcontroller, like in 2010, if any even existed at that time, is different to what you'd pay now. Now, obviously, like I still can get decent 100 megahertz chips that don't have these like shitty softwares that you're mentioning. So is your problem more a question of you are maybe selecting something lower in the market right now, but even if you're to get the better one, all right, it would be cheaper than what it was 3 years ago. I don't know if that makes a bit of sense, that it's more a question of what you're choosing in the market right now, as opposed to the overall market having that critique, where by all metrics, the market in terms of hardware has gone down, all right, in terms of price. It's cheaper to make these things. And if I feed it back into your startup problem, I'd say that you come back to these two variables, and I'm trying to correlate them so that you can be able to draw a nice fancy trade-offs graph that says I've got cost, all right? If I try and control too much, it's expensive because the devices are expensive, all right?
Yeah.
But if I lose too much control, I also lose because there's all these dependencies that can make my business break. But then I'm bringing in another variable. I'm saying, but hey, you've got this interesting trend that's going on where the devices are getting cheaper. How will that change your graph, your trade-off graph between cost and control, such that as a startup today, I'll take an example. If I'm building an industrial robot, for example, and I see what Google's about to do with making things cheaper, better, faster, I'll kind of adapt my business model a little bit. It opens up new avenues that says, okay, I can maybe now start having more control of this aspect of my product because Google has done the heavy lifting that would have made this thing more expensive. So where I would have centralized at a rate of 2x over, let's say, 5 years, I can now centralize at a rate of 4x within the same period because of the market dynamics that are happening in terms of the hardware getting cheaper. I don't know if that makes sense. I feel like,
No, it does. It does.
Yeah.
So I'm trying to obviously quantify it from not just in general, but then using a use case that I'm currently on, or that I'm aware, I guess, personally. So you mentioned something which is, yes, every year hardware should get better. It getting better essentially makes the whole thing cheaper, right? The problem is, which I've indicated, that's not the case, right? Which is the hardware supply. You won't have the same product that you bought 3 years ago. That would be lovely because it will be cheaper, but that's not the case. They give you a new product.
Oh, okay.
With yes. There's like a cycle of some sort. Every now and then, I don't know whether 6 months of it, every year, whatever, you can't get the same product that you've got. If you got it, that would be perfect. That would be hallelujah, because you know definitely it's going to go down in price, but that's not the case.
Okay, cool. So you're in a unique situation where obviously you don't have the power to lock an OEM to give you a fixed product over a long duration. So you have to
Yes.
keep looking at the market. I guess the first question in my head is
So I have to keep, so the major thing is I have to keep with the market and also with the technology. I have to always be up to date. If I don't, my software breaks because now I'm getting a new product which is great according to the new market. It's following all the nice shiny things, but then my software, maybe it's on, let's say, for example, I'm using Android, it's on Android 6, not Android 10. So it doesn't work. So I have to now always be up to date.
No, I see. And Android doesn't do a good job of supporting hardware for a period. So that's already another like limitation.
Another layer, yes.
I suppose, like in your case, obviously, I can see where the deadlock happens. But if I were to try and generalize it, certain other use cases you can see can have these, you can call it unicorn opportunities, where suddenly this thing that was expensive is now very, very cheap. Like, for example, if you wanted to do AI on the edge, I'd say 5 years ago, I mean, you just would not see that. You would not get that. But now it's like almost like dirt cheap to basically put a model on a device and do some inference kind of situation that will detect like an image, whatever. It's very, very cheap and accessible to do that. But as you're tying it in, the market is also demanding that. All right. So even if next year things get cheaper here, in terms of the what you call it, the device and its capabilities, etc., the market will demand more, which means you also need to upgrade. So I can see that equation and draw it out, but this is kind of like I'd intuitively say that a lot of what we call the so-called economies of scale, all right, that we see, let's say that Apple and all the likes hit when they manufacture stuff, relies on this relationship that at some point the graph starts to lean towards things being a lot cheaper. All right. And I don't know why. All right. I can go down to the physics element of it, that because you create a market, and I think Apple does a great job of it. All right. They are charging you more for the iPhone. All right.
Yeah.
But it's not necessarily true that it's costing them more to make it. All right. But at the same time, they're driving an entire manufacturing machine that can be feeding into other product lines, which are benefiting from what it's doing. All right. So that means that you see a classic example of it with the Chinese.
No, that one I like it because that's like a 101 way of making money, right? You just need to make sure that you diversify, make sure that you have multiple sources of income. So if you can do that, then you're not essentially dependent on one. So that's why if you VCs as well, they want to see what's the source of income. Are you only dependent on one thing, or there's other avenues that you can look into to make sure that, okay, cool, if this one is sort of stagnant, but then there's other things that making money, software-wise or whatever.
But I don't mean like Apple itself. Like, I think like you've got the machine that exists to build and feed the machine that is the Apple consumer market.
Yes.
All right. But what Xiaomi and even Huawei exposed is that, hey, it doesn't cost $1,000 to make a device. It maybe costs 100. So I can tap in, make the same things that Apple does, but I now charge it at, let's say, $300. So they're benefiting from this infrastructure that Apple and Google have built, and Samsung, but they're now realizing that they come in and actually build other product lines benefiting from this machine, but and start chipping into Apple itself to some degree. All right. So
okay, let me pause you here. I don't understand what you're saying. I want to understand.
All right. So I'll use a practical example. All right. So it's day one. All right. Apple needs to make iPhones. All right. And so they set up a manufacturing shop that is, let's say, building chips. All right. And screens and whatever. In the beginning, it cost them a lot of money. All right. And so you find that I actually remember the days with the iPhone cost, I think, $300 or $350. All right. And so that's how like cheap it was. But obviously, I mean, it's more the relationship between how much it costs for them to make it and how much they're selling it that is relevant for my point. So Apple builds an infrastructure because as the consumers and the market grows, it becomes more economically viable for these manufacturing companies to specialize, let's say, in building more chips and specialize in, let's say, having a warehouse, etc. So what you have what I mean by a machine, I mean that Apple and the whole smartphone industry have created a very reliable and robust smartphone manufacturing hub. All right. Now, what they've done is obviously because they've got this machine, Apple tries to scale because they know that it's always costing relatively $100. So they try and bring in, like you're saying, diversify services, all these other things. And they've been doing the nasty deed of making the product itself more expensive. But the core point I'm trying to make is that Apple, in building the machine, all right, is also benefiting other players that can come in and tap into that same machine and benefit from it, where if there was no Apple and there was no machine, it would have been harder for them to do it on their own. So Xiaomi's and all these small little players like Oppo are basically riding on this massive smartphone industry, which Samsung and Apple have built, but they can come in and make things cheaper, all right, than what they would have been able to do if they were to do the work that an Apple or Google did from scratch. So what I'm trying to say is
that's not the same. I get your main point. Obviously, what I'm going to say is it's going to be a tangent, but then that's not the same. From a machine perspective, sure, I understand that part. But then from what Samsung and Apple is offering, it's not the same. Like, it's not the same as what those guys are offering.
But you see, that's what's debatable, because if you look at the market, for example, Xiaomi has just surpassed Samsung in terms of smartphone sales. So that already tells you that in terms of what the market perceives in terms of value, is that even though Samsung is obviously hypothetically offering more, these guys at a smaller price point, because it's not costing them any less or more to make the smartphones than Apple or Google. We all know chances are they're probably getting it from the same manufacturer. So relatively it costs these guys all the same to make the hardware. All right. Obviously, there's the extra things. Apple has the marketing element to it, which, to be fair, there's the brand value, which is why they can bump it up to whatever. But I'd argue that the market is starting to value these guys a little bit more. All right. Which is why we're seeing the numbers starting to flip. All right. And we're seeing Apple's numbers starting to, let's say, stagnate from a hardware perspective, because they've kind of hit the ceiling to some degree there. And yeah, so I don't know if you want to speak to that.
No, I wanted to, like, for this discussion, especially this one in particular, we need numbers. We can't just talk in jail. So we need numbers. What I mean by numbers is why people buy. Numbers in terms of reliability. Yes, numbers in terms of reliability, right?
Okay.
So for me, I'm talking about Samsung and Apple from a reliability standpoint, right? People jumping because of now, okay, cool. Highway, it looks more high-end, then I'm jumping in. But then from a reliability standpoint, how reliable is it? Obviously, we can go into the whole aspect of, say, okay, cool, what do we mean by reliability? So I can say, how many people actually buy that phone and keep it for 3 years, and nothing happens, nothing weird happens. It's just reliable in that period. We know Samsung does that, we know Apple does that, and then even though now, before they were using the whole thing of 2-year cycle, now they're using the whole 3-year cycle. So with those guys, even though they look premium, now you can see with the Huawei, people are moving towards that because now it looks premium. But then back in the day, probably like 3 years ago, I used to tell people, but it's the same quality, right? From an engineering standpoint, I'll be like, whatever you guys like, people used to hate Huawei. I'll be like, why? Why are you hating Huawei? They're like, no, I don't know this product, blah, blah. Now people are loving Highway. I was like, the same guy that I talked to 3 years ago now loves Highway. But like, what changed? The main thing was the perception, and it looks more high end now. I can use it for my girlfriend, and then people will see that I have money, blah, blah, blah. But then what actually changed? The fundamental things for me, what beside the perception, just from a hardware reliability standpoint, what actually changed?
It's a good question.
Even though it's remember, it can give you the same output, maybe for 6 months. It's the best thing ever. But is it reliable for the next 3 years? Can you rely on it properly for the next 3 years? In the same way as you rely on an Apple, same way as you rely on an Samsung. I don't know the numbers for that.
Okay, cool. So what you're tapping into is an interesting question. It's a nice challenge. How do you put numbers to it? And how do you get out of the opinion space and try and formulate an objective metrics? So what comes to my mind is that, okay, cool. So you have a spectrum of what consumers care about. Obviously, price is one of them. Reliability is one of them. Perception, marketing, all that stuff is all in that bag. All right. So that's the one complexity to quantify. The other one, which is, or maybe to just cut the long story short, my thesis is that all of those things should be factored into the consumer behavior. So if I study consumer behavior as a whole, I can, without trying to delve into why, reliability, whatever, I can overall know that, okay, cool. Overall, the market is valuing Xiaomi a lot more on average than Samsung. Full stop. All right. Now we can get into the nitty-gritties of what has changed.
So that's why I'm saying, do you, as Fabrice, I don't care what the market does, do you, as Fabrice, value that? Like I said, I give you my metrics. My metrics is like, is this thing reliable for 3 years? And can I get something that supports that? If not, okay, cool. Maybe it's not I can only rely on this thing for 6 months. Maybe that's good enough. But then for me as Bongani, I have my three-year mark, and then needs to be performant at that time I bought it, maybe relatively within a certain margin, of course, for 3 years. So for you, is it like right there in there, 6 months, everybody loves it. Next month, they get something else. And then for the next, let's say 2 years, they're always complaining that my phone is breaking, my phone is freezing, my phone is heating up, my phone is da-da-da-da-da-da.
Feel like you're doing a lot of trash talking there, but okay. Personally, in general, I think the overall quality of these devices has become better. I'll give an example. Like my wife bought the poker phone. It was like the 2019 Holy Grail.
5K one.
It was $300 smartphone, and it was the same time. Well, 5K was what she got it for. It got at the same time as I got my Note 9. It had almost the same specs. I've looked at both of the cameras. It's still running right now. It's still pretty decent. It's still high end. The pictures are still amazing. So from my experience, it does feel like the overall quality of these devices are competing, meaning the cost to the value proposition is the same. The cost to what you're getting ratio is higher.
That's why I was coming in.
That's why I started with the market.
No, that's why I was coming with the whole aspect. You can get, especially with the hardware and software debate, you can get to the element of saying, okay, cool. You, Fabrice, you bought your Note 9, and then the wife bought a Poco. So if you buy those things, hardware-wise, is the same thing. Using same hardware, camera, sensors, etc., etc. But then, obviously, now to make the whole experience, there's the software layer. Does the software layer combine with the hardware layer? Does it give you the same feeling? Is it the same thing all the time? Is it better? Because sometimes you get a very high-end phone in terms of hardware spec, but then the software doesn't make it better, and it just sucks. The phone, maybe the sound quality sucks, your picture quality sucks, your video quality sucks. But then from a spec perspective, like fudge, this thing is like on point.
Yeah.
So while with Apple, with Google, for example, they will use a lower end, same thing with Apple, they will use a lower end hardware, but then what they can do with software on top of that makes it like it's like the best thing ever.
Okay, true. I think in general, it's like there's so many ways to look at it. I would agree with you on specific things, but on other things, I kind of don't agree. Like I've been hopping between ecosystems, Apple, Android, and what I can say is that generally I see a decline in the value proposition of Apple. Like for example, the MacBook, like that line of MacBooks from like 2015, 16, that was amazing. You could feel that you've got a Mac, the performance, all that stuff. 2019, I've got this MacBook, and I was actually telling my wife, if I'm honest with myself, I've actually found this MacBook very disappointing. All right, it's supposed to be the high-end spec last number, but it's not delivering the same ratio of, let's say, performance or value that I felt the older MacBook did. All right, and I think that what's happening is that guys are going back to Windows. Like, don't you think it's so weird that like Windows has become like, we are open, bring us Android, we want to do, and Apple is still the archetypical, basically there's a reversal of roles that I feel is happening between Apple and Windows. But that's a side point. But my point is that I'm seeing an increase in the value proposition that no-name brands like Xiaomi are bringing, all right, versus what Apple is doing. So I'm almost seeing something like this. Traditionally, yes, I agree that they do offer better, but I myself as a fan am valuing it less. All right, I'm realizing that, I mean, what's the point? Like, I got this, it's not as great, it's not as amazing. It feels like it's underwhelming, but when I paid so much for this, I felt like I wanted to get the ultimate experience. But now my wife has a phone and she's got almost the same experience as me. I felt it, my Note 9 and her Poco phone, there was like no difference. And it literally put that question mark. What was the point of getting this? Even if you take into consider the software, the branding, etc. And that's what I think the market is realizing and the market is factoring in. And that's one of the things I love about capitalism, all right, is that the market is never dumb, all right? People at scale will reflect and summarize for you the complexity of all these variables that you're trying to look at. I.e., I think on average, people have sensed that the value proposition of these smaller brands, all right, is a lot higher, all right? And essentially, their proposition is, we'll give you the iPhone or Samsung experience at a cheaper price. Now, in terms of the reliability and all these different things, I think when you come back to my analysis of all the different things that contribute to a consumer's analysis, I don't think reliability is on the top of it. And that because it's also of the consumer psychology. All right, the market cycles are moving. I'd almost say there's a point where it was moving really fast, but it's kind of slowing down because of the quality of the products themselves. But there's just that general idea of getting the new, latest, coolest thing. All right, my sentiments lean towards that, and you know it. When something cool came out, I always wanted to be the first one to get it, first one to try it out. Like because I'm not obsessed with having the same experience consistently over time. I'm obsessed with having a new experience. All right. And then there's just also consumer habits. The fact that a lot of these industries are reliant on other markets and their trends. So for example, most people will buy high-end smartphones on contracts. And these contracts will run typically over a 24-month cycle. So that means that can already map to, if you talk about the reliability of a phone, all right, and the specific financial market model, you can already see that, like if I'm stuck on a 2-year contract and the phone only works for 6 months, that's a very shitty experience. And you'd find that like there would be a market effect of that, meaning people will be less likely to get certain phones on contract, which is the case. You won't find people buying like a, I don't know, Xiaomi that's on contract. They'll go for the high-end stuff and so I can almost argue
Well,
that
for the high-end stuff because you can't get them anywhere else but contract.
true, all right.
I want to
And
buy my one cash. I can't. I have to go to China or something like that to buy them cash.
yeah, that's what Ipileng had to do too. She had to order the thing on contract. On what was it, Banggood? All right, one of those guys. All right. But I'll end with this last point is that because Apple knows that it's intertwined in this more complex model, just take the basic, everybody goes on a 24-month contract. It knows that one of its core requirements is that our product needs to survive for 2 years, or else there'll be a market reaction to this. So that only means that they design and they build around this life cycle, knowing that after 2 years, we kind of sort of don't really want you using it. Hence, we saw the nasty shit they were doing with the whole software update they did to help you optimize battery life, which was basically a trick to just start getting you to move on to the next product. So as opposed to Android, where we also see they just don't release updates for things that are maybe even go beyond like 3 years. So, and that leads to that complex question of where engineering is no longer about making the best product, but it's about making the best product that meets your model. AKA, you can have engineered failure, meaning I don't want you to have a phone that lasts 10 years, even if I can build one. Even if I can make a chip that is 10 times faster next year, I want to make a chip that's first 3 times faster and then release that to the market. And then 4 times faster and release that to the market. So I think with companies like Apple and Google and stuff, that's kind of like how I tend to analyze them is their model, the environment. There's now consumer habits too. And all of these things are complex and we need numbers for them. And the only number I can see is to look at consumer behavior, which for me is an integral of taking all these, after Apple has done all these things, all right, the consumer's actions and responses give you an indication of what really worked. And
and then can companies give us reliable products that can last for a long time?
Definitely.
Or is it a calculation that they do? Because we know right now, all the reliable stuff that we have, they're running old stuff, right? Old technology. Yeah. But then the ones we're running right now, the latest ones, they keep on changing. But then can we have a latest thing that can last for a long time? Or is it now a major problem? Is it something that the companies are like inherently making it to do that, even though they're capable of doing that? It's just that now they're making sure that this thing can last for 3 years. After 3 years or after 2 years, then let's jump on another product.
Yeah, I actually think it's something really genius. The fact that these companies can, for lack of a better word, engineer for different quality requirements. So we know, for example, you've got these factories in China. Everything we consider to be high-class standard comes from China too. But you might find that factory knows that I can make the $1,000 quality version of this thing, or I can make the $10 version of this thing, which is why you'll find you have Adidas and then you have Adidas with the 5 stripes. They come out of the same factory or similar factories where we've now at this point in our engineering where we can actually control the kind of quality that we want. So engineered failure, obviously you can get all conspiracy about it. Oh my God, they're just doing it to screw you over and make money. I think there generally is a trend towards companies building better things that are faster, because you must remember, they're also in competition with other companies. So it means that you don't always have the control to say, okay, I only want to jump 10 meters high, because at the end of the day, your competition can jump 20 meters high and then basically drive you out of the market. A classic example of that could be like BlackBerry, how arrogant they were at the time that Samsung and the iPhone was coming in. I mean, Android was there, they could have pivoted. they could have tried to take a bigger leap. Now, you could argue they couldn't. Maybe they didn't have the ideas. It's hard, but I generally tend towards the fact that they most likely could have if they were aware of if the incentives to do that were more explicitly clear to them. If BlackBerry knew that you're at an existential state, you need to innovate at this level to, let's say, remain competitive, they would have responded accordingly. So it was more misjudgment, obviously from the higher ups, all that kind of stuff in how they analyze the business environment. So I'd come back to the core question of this problem of products not necessarily being better and engineered failure. I think it's so many complex variables, all right? And you always need to find a way of summarizing it. How do I get to the point where I look at Apple and I can assess whether or not this product is basically shit? Like, you know how when any new phone comes out, we're like, they've done nothing new. It's the same thing, you know, but yet they're charging it more expensive. How do I quantify this new? I was excited about LiDAR, for example. And you heard, I mean, when it came out, I was like, this is going to be groundbreaking. It's going to revolutionize AR. It's going to add more abilities for developers to build amazing apps. But it's been like almost a year. No one's using that shit, right? I mean, like, so there's those elements too of like, is that a fault on Apple? Like the costs that they've invested in bringing LiDAR, which is typically an expensive technology, by the way, all right, into the hands of an ordinary consumer product is impressive. And it might be that in the spectrum of, you know, if you draw the bar graphs of all the things that go into making the phone, it might have been very expensive. And what I'm interested in seeing is how exact is their science in how they determine what to focus on versus the price versus the consumer. Meaning when they decide that, okay, cool, we're going to make it $1,000 and we obviously need to bring a new value proposition to the consumers. What's the relationship between what they choose to invest in and like obviously what consumers eventually like value? Now already I'm already shooting myself in the head because if they really knew that, they'd always be experts. But clearly they no one has mastered the art of predicting the market. Else, or have they?
I think it's safe for them actually. It's safe for them to continue with the model. They should not introduce something new in the market. They fail when they do that.
You reckon?
Yeah, they just need to let other people do it first, and then they come in and do it best.
Yeah, maybe
mention one product that they've come up with, and then they were the first, and then from there they killed.
Okay, obviously we have to mention. I doubt the iPod was from a patent perspective the first, but from like the market, you can argue that they kind of, this is something that they opened.
No, that's what I'm saying. There's no product out there that Apple actually came up with. It was the first to be seen.
No, but in terms of like widespread, like there's levels to this. There's like,
yeah, that's what I'm saying. Yes, even though there's like maybe 5 people only saw it at that time, and then other people, when Apple came in and then they make it worldwide, the main fact is that they're not the first person to come up with it and then make it go boom.
Well, I would argue that the iPhone 1, that whole touchscreen experience, whatever, it was
That's
quite
been done before.
It was done before, but the other caveat to your criteria is widespread. All right, there's done before.
So the nice element to it. So the touch thing, that was great, but then it's been done before. Even Nokia had a phone with it, which they proposed never came out because obviously internal politics. But the main thing about Apple at that time was their, I'll say, the way their keyboard was designed. That was purely from them. no, they didn't take that element from anybody.
Yeah.
That's the nice thing about it that made it actually work. The other ones didn't work because the keyboard didn't work. You couldn't properly type. The whole thing of
Auto-correction.
autocorrection, that's their invention. That's the whole thing that made the capacitive thing to work. Besides that, it wouldn't work. You couldn't type.
No, it's a good point. And that's obviously modern day Apple is not the same as, Steve Jobs' Apple. Definitely. I mean, but I guess actually, maybe this can be a nice segue to maybe land this. What do you think about Apple? Basically, there's strong rumors. Basically, Apple is going to build their own autonomous vehicle, right? They want to get into the EV space, all right? And obviously, how do we know these things? Usually there's leaks. They obviously start hiring a lot more engineers for a certain discipline. Obviously, engineers speak. So rumors out there that they're building their own EV. And how do you think that's going to play itself out? Do you think he's going to topple Elon? Or will they fuck it up and just will it just be an AWS Google cloud service thing where they'll share the market, or will they become Apple in the EV space?
Okay. I think the closest thing to that is the latest product that they released.
The AirTags.
Which one?
The AirTags. The AirTags?
No, not AirTags, not AirTags. There's a previous one that they jump into oh yes, your card.
How's the Apple Pay?
Yes, how's that going?
Actually, I'd like to see what the numbers look like in terms of adoption, but I know it's definitely not going great. All right. Well, let me see. I'd have to look at the numbers to be sure.
Yeah, we have to look at the number, of course.
Because one thing I know for sure is that because it's Apple, it's not failing because it's in the ecosystem. So Apple Pay is probably being used by a lot of Apple users. But I would say that I don't think it's thriving. AKA, it's not like competing with PayPal or Stripe or any of these other payment gateways. I don't think they're there yet. Yeah.
Yeah, because obviously that was obviously you can see they're aggressively trying to jump into a different source of income. That much we can see. We know they love the finance space because you can make a lot of money into there. Then they're trying to jump into the whole credit card and whatnot. And then maybe other people are trying to come into it using a blockchain. And then they can see, okay, cool, the EV space is more lucrative and people, a lot of, not lucrative, but then there's a hype to it. And then obviously, as usual, they just want to get into the hype and make it better. So with that, can they come in and make something better? From a software perspective, yeah, sure. But then they have to, for them to do that, they have to be in partnership with a great hardware partner. So who's that? Is it, it can't be a typical manufacturer. It has to be a high-end, luxurious feeling. Your Mercedes, your I guess your middle ones, your Mercedes, your BMs, then you go high-end. Your VW, no, that's not high-end. VW is low. I'll say high-end version of VW is Audi. So let's say Audi. And then let's go higher end than that. You'll say your Bugattis, your Ferraris and stuff. Maybe your Porsche, yes. Maybe they can maybe go into those space, but not. I don't see Apple going to like because they love control. They need to control everything that happens.
Yeah.
So if they have to I guess integrate with Elon also likes control. So can they meet each other halfway? How do Elon
apparently there's a beef. There's a rumor. Okay, it's not a rumor, but allegedly, at some Elon struggled with Tesla. Especially in the early days. Apparently, he tried to have an interview with Tim Cook to discuss the possibility of selling Tesla to Apple, and apparently Tim Cook did not return the call. All right. So they've been throwing little shots at each other on Twitter and stuff like that. But yeah, basically it seems unlikely that they're more likely to be competitors than ecosystem partners.
Yeah.
And what's good about Tesla is they obviously invested in the charging station infrastructure, of which they recently have said they are open to other companies basically using their charging stations. Now, obviously, you know, it's a great thing, of course, but obviously you can imagine
it works out. It actually works out. I think they're following the Google model, which they see. I think they're trying to do that because of their stock, where on their side, they're presenting it as a way of saying, okay, cool, we want the community to be on board, and so that the whole space be moved forward very quickly. That's the selling, the whole selling pitch, right?
Yeah.
And if you look at it from my side, I'm just saying they're stuck. They don't know what's next. They can't innovate as fast as they were in the beginning. Right now, they need other people to come in and also add new ideas without actually them hiring, right? So if they do the open source model, it helps them. It helps this ecosystem because they're already winning with everything else, but then they can afford to actually give the IP that they have to other people to build on top of that and make sure that the space grow exponentially.
No, it's great. And you see, it's similar to what, like, I'm glad you pinpointed. It's a similar thing to Google. I love it when big players do these kinds of moves, where you see a relationship between their self-interest and them also doing something that obviously benefits the ecosystem. And for me, that's the kind of shit that I want billionaires to do. You know, it's like how, if you can diverge into more lighter stuff, how everyone was going on about these guys going to space, you know, like, why are these billionaires going to space? Why don't they just give all the money to save child poverty? You know, and I'm like, they're not the only billionaires in the world. And if billionaires were to exist and to spend money, I would rather they chuck their money into that space, because obviously the secondary benefits of them investing in these things are huge, and we benefit to some degree from them.
Yep. Yeah, so that's the whole thing. Now, in closing, if we're going back to the whole scalability, hardware, and whatnot, how do we close that?
I'd say that, like, we went down a lot of rabbit holes. There probably were quite a few other caveats to explain. I suppose the only thing I would say in closing is that it still is hard. The order of difficulty has not changed, aka let me coin something. You've got space complexity, you've got time complexity. I'll call it scalability complexity. All right, it has not changed. All right.
Yeah.
But there's some interesting trends that I would pay close attention, aka the reduction in costs of these devices. The price is going down. And how do you use that to basically get more control? And that's kind of like what I'd summarize it as. It's got these two variables you pinpointed. The devices are expensive, and I don't have control over, you know, how these devices, how often they're supported, you know, whether the quality, all those variables that come with manufacturing. How do I use the fact that the price is going down to adjust my business model to get a little bit more control? That's kind of like how I'd summarize the question and kind of like scratch a little bit more on. All right.
Okay, cool. So then that means now, obviously, it's always going to be difficult as a startup to jump into the whole space that actually touches somewhere hardware-wise. And now to make it cheaper, yes, software you can a bit control to make it both cheaper, but then you need bigger players, like you mentioned, your Googles and whatnot, to come in and try to bring the price down. Even though they're bringing the price down, they need to we need to have a layer which makes sure that we have the same hardware, cheaper price, but the software actually also improve.
Yeah.
If we can get something like that, then we great. But then will it work for economics? Maybe not. But then for South African context, or for like startups context, that can work. How do we get that? Do we get a China on board? Do we get like a South African government to come on to play and get hardware players to say, okay, cool, let's support these lower end guys, right? Let's give them something that you can't change a lot, but then it's like good quality. How do we do that? Do we leave it to the market? We know we can leave it to the market.
Yeah, the market can't. Yeah,
will continuously improve and change. But then, how do you keep something the same, which is hardware, having hardware the same and software incrementing very fast? That's like what we need to get to, because hardware doesn't change a lot relative to software. So
true.
now hardware is actually trying hardware is trying to match that pace
to keep up.
And then how they do it, they just rebrand, get the same hardware, but then they change a few things and the software is a bit different, and then boom, here's a new thing. So keep the hardware same and just continuously change the hardware. Why can't we do that? And somebody can say, yeah, sure, you can do that yourself, but then I can't, because for me to do that, we say, yes, I can get a device and then change the operating system every year as it comes out, but then I'm not guaranteed to get the same device. That's the problem here. Guarantee of getting the same device. And then if I get the same device, then I'll continuously change the software. But then if I do that, I'm not actually guaranteed that me changing it myself can actually, it will be compatible to the hardware. But then if I've got an OEM who does that for me, they're making sure the compatibility is always on point all the time. Same software, but then same hardware, but then software changes every year. Perfect. The same way we're doing phones. With phones, you can get the same phone, and then when Android changes, I can just download. Let's say Samsung will get it and make sure it is compatible. Change a few things on the OS. Eventually, it works with the camera and everything perfectly fine, and then they ship it to you. So right now, I don't have that middle layer that can take what's out there, which is the hardware, the old hardware and the new hardware. I don't have the time to do that and make sure I've changed it accordingly so that I can continue with my business.
Okay. So I think maybe we'll end it there. And it's something you touched on, we can chat about maybe in the future, is this problem of the ecosystem. Because it seems like that becomes a critical thing, that if you have an ecosystem that has certain infrastructure, certain startups thrive. And then when an ecosystem lacks that, you find, and obviously when you're a startup, you can't solve ecosystem problems and still try and build a startup. So I think one of them we identify is the lack of basically cheap hardware that is consistent. All right. So yeah, so we'll chat about that in the future. It's been a very long chat. This is probably like what, 2 hours, 2.5, if not 3.
Yep. I'll just break it down.